In terms of giving the program and the system confidence that we could have safely approached the station, we went through a lot of ground testing, everything from the communications links to the command algorithms, the abort criteria. All of that was tested in detail with NASA in the loop. We had a lot of integrated simulations between our control center and the Houston Control Center to test these kind of things, and not just the system itself, but the human in the loop, the logic that was being used for establishing criteria for either a back out or an abort. And we gained confidence between the two of us, even when some of the problems were artificially stimulated, if you will, by the system itself and not by the actual design of the spacecraft or the ground control system. And because people learned to handle these kind of unusual and unexpected things together, and we'd establish a good rapport, I think that helped a lot once we got on orbit. And then on the demo mission, when we did have the problem with the software, I think it allowed everybody to speak openly about what was going on. Everybody had a good background on how it was supposed to work and how it essentially would recover from this particular problem. And then by the time we got in close, everybody was on the same page. What that did, I believe, is give us confidence for the future missions that if anything unusual did happen, we had the means of dealing with that. And even though you train, ad infinitum to whatever you think could happen, it's always the unexpected that really tests the team, and you have to demonstrate your flexibility, but also your depth of knowledge of the system. And I think we showed that early on, and it helped make the next two missions go much more smoothly. In terms of dealing with what requirements we really had to meet in order to approach the station safely, 5808 was the Bible, if you will. And we spent a lot of time discussing with NASA, both on the operations side and the technical side, what those requirements meant. And we had very good dialogue with the NASA team and amongst ourselves on how to make sure that we complied with those, not just the requirements themselves, but the intent of the requirements. So sometimes that would require some negotiation between the teams on what does that really mean, and what are you trying to achieve, and what is the impact on orbital ATK, what's the impact on the system, on the ops team, if you implement it a particular way. It was very rare for NASA to come in and say, this is hard and fast, you have to do it exactly the way we want you to do it. We were almost always given the opportunity to say, okay, we understand the intent of the requirement. This is how we think we should implement that and ensure that both your requirements are being met and our requirements are being met, and the overall intent of safely delivering the cargo is met. And it was a really good and healthy dialogue between the teams in that regard. And that occurred not just in flight, of course, but all the way leading up to a flight, through the flight readiness review, through all the previous reviews such as CDR and PDR. Why do we have to meet these requirements, and what do they mean? And then when necessary, they'd be clarified, or we negotiate changes with them. And there was a little bit of quid pro quo in that, okay, if you'll add some redundancy here to comply with this requirement, then we'll back off a little bit on this one because we think you're meeting it in other ways. And that was a very reasonable approach in our opinion, and I think healthy in that it made the system stronger, and that both sides understood it better, rather than one side saying, you have to do it exactly the way we say, and we're not going to tell you why. I mean, that's what I've seen in the past, and that's a very difficult and in some cases dangerous approach.